And in this talk, I'm going to show you what is metaprogramming, different techniques of how to do or how to develop metaprogramming with Groovy, and I'm going to show some theories, some explanations, and a lot of code. All the code it's on GitHub. I'm going to push the code to my GitHub account after the talk. So let's start. Who am I? I'm Iván López, at Pilotmar on Twitter. I work at Kaleidos. We are a technological company. We mainly develop web applications. We have two different teams. One team use Groovy and Grails. Another team use Python and Django. Of course, the Groovy and Grails things are the best. And we have one type of principal customer. They are entrepreneurs that have money and have an idea, but they don't have the technological team to build their idea. So if you have money or have an idea, we can talk later. I've been using Groovy and Grails since 4 years. I think I started with Grails 1.1, sorry. I created boxtree.com, a social network developed with Grails. I developed some Grails plugin and Postgresql-Extensions and Slug-Generator, that's our API, and a lot of them. And if you are using Postgres in production, I highly recommend you to use that plugin. With that plugin, it provides hybrid user types and new criteria to use native Postgres types such as hstore or array types. And I am a usual suspect of the Groovy user group here in Madrid. So, Groovy is dynamic. With a dynamic language like Groovy, we can postpone to or delay to runtime some checks that are usually done during compile time. We can add new properties, we can add new methods, new behavior to our code. And we can develop, for example, DSL, builders, advanced logging techniques, tracing. This dynamism allows us to organize our code base better because we have this code in one place and not spread all over our code. And because of that, we can talk about metaprogramming in Groovy. So, what is really metaprogramming? Imagine that you can add behaviors at runtime based on the current state of your application or the inputs your application receives. This would make our code more flexible and we could be more creative and productive. You don't have to imagine that. It exists and it is called metaprogramming. So if we go to Wikipedia, we can read this definition. Metaprogramming is writing computer programs that write or manipulate other programs or themselves as their data. That's important. Or do part of the work at compile time that would otherwise be done at runtime. We can say something like, we are writing code that writes code. Groovy allows us to use or provide runtime metaprogramming and compile time metaprogramming. Almost all the talk I'm going to talk about runtime metaprogramming. Also at the end, I'm going to talk a little bit about I'm going to talk about runtime. At the end, I'm going to talk a little bit about compile time metaprogramming. With runtime metaprogramming, we can postpone to runtime some decisions, and we can intercept, inject, or synthesize new methods on the fly. So, how does Groovy do that? It uses the Meta-Object-Protocol. And we can hook or use this mock to hook into the execution and create new methods, add new properties, and new behavior. How does it work? Groovy doesn't call our code when we develop Groovy and call another Groovy or Java code. These calls are not done directly to the final code. They are done through this mock layer. And Groovy provides some hooks here, and we can intercept that execution. It's important to understand that when the Groovy compilers compile the code, it generates bytecode with these hooks. That's not really true because there are some optimization, but from our perspective point of view as developers, this is always true. In the right side, if we are developing Java, we always call we always do these calls directly. So we can intercept methods hooking into the mob. When Groovy compiles code, all classes implements a Groovy object interface, and we can implement Groovy interceptable interface in our classes to hook into the execution. We have this method that will be called when a method is invoked, we get accept or set a property, or when we change or get the method class. For example, if we implement invoke method, all these calls to this class are going to pass through this method, even if that method does not exist. So here is a little example. We have a class that implements Groovy interceptable, and we are overriding or implementing get property and set property. Here we create a new instance. So this will be something like this dot get name, and it will be called again hook or catch by this property, by this method, and we get an stack overflow error. With the add symbol, we access directly to the property. Now here we are implementing the invoke method. So all the calls here, I'm going to go through this method. We create the new class. We execute say hi method that prints hello Greach, and this will be executed invoke method say hi with these arguments. And here we're getting this implementation from the metaclass. We'll talk a little bit later. And if this method exists, we're going to invoke it. If the method does not exist, it will not throw it will not throw a null pointer exception because we are using the save deference operator. Also, you have to notice that here I'm using system.out print line. If we just write print line, this method will be called when we use print line, and we get again a Stack Overflow error. So I've talked about metaclass. What is metaclass? For every class in the class loader, Groovy maintains a metaclass that stores a collection of all methods and properties for every class. And even if we can modify the source class or the source code of, or it is even Java code, we can always modify from Groovy its metaclass. So we can add this new behavior at runtime. We can implement, for example, this method, this invoke method in the metaclass, and it will be called. Here it's the same example, class hello with this say hi method, but we are not modifying the source code. For example, it is a library, or we can touch that code, but we can always implement this method into the meta class. So again, when we execute say hi, it will be the same execution as the previous example. Now, in the previous example, we show how intercept methods, and now we're going to inject methods in runtime. This is method injection. When we are writing the code, we know the names of the methods or the properties we are injecting. And with Groovy, we can always open a class. I mean, imagine you want to modify a Java class like a string that is Java lang string at its final. In Java, we can do that. In Groovy, it's pretty easy to modify the string class. And there are different techniques that I'm going to show you. Method class. These are some implementations of the method class that Groovy provides us. The metaclass imp is the default metaclass implementation. It's used almost by all of classes. And when we add new behavior to that class or to one class, Groovy changed this implementation to expand metaclass to expand the behavior with our new methods or properties. Groovy also provides proxy metaclass that we can decorate a class to intercept, and there are a lot of other metaclass implementations that are used internally by Groovy or are for testing the framework or the language. Here we have a utils class. How many of you use something like that? String utils, date utils, and in which you have a lot of static methods. For example, to parse a string to a date or something like that. Here I have this method truncate that receives a text, a length, and an optional parent, and it will truncate this string to this number of characters. And if the overflow parent is true, it will print these 3 little dots to note the user that there are not a lot of text. For example, you can use this where you are displaying the comments of a blog post and you don't want to display a 2000 character comment. You can truncate to, I don't know, 100, and with this overflow property and a label, I don't know, read more, it will be expanded in the front end. And we have here Chuck Ibsen. If you can see Chuck Norris, he can see you. If you cannot see Chuck Norris, you may be only 1 second away from death. So be careful, because Chuck Norris is here. And we can execute this. String utils, truncate, Chuck Ibsen, number, it will print this. And if we pass this parent through, it will print these 3 little dots. And it's fine, it works. But we are Groovy developers. We are not Java developers. We can do this better. How we can do that? We can inject this method into the string class. We add this truncate method into the method class with the length, the overflow, and the same implementation. Here, the delegate is the value of the instance on which this call is executed. So finally, we can assert that Chuck Ibsen and string instance dot truncate is equals to calling our string utils class. We can also add properties at runtime. We have an empty class utils. We create an instance and check that the metaclass is the default metaclass implementation. Now here we're adding 2 properties, version and release. One version is added to the class, release is added to the instance. Now we can check the new method class implementation. Groovy has changed to expand the method class. And finally, we can assert that the instance, notice that here we are modifying the class, has these 2 properties available. And we can also create new constructors. The integer class does not provide a calendar instance constructor. If we execute that code, it will throw an exception. But we can add a new constructor that receives a calendar instance. So finally, we can create this new integer calendar instance. It will print the day of the year that for this instance. And we can also override methods. Here we can assert that the string representation of 42 is 42 in string, 42.string. But as we all know, or at least we all should know, 42 is the answer, the life, the universe, and everything. So we can override the to-string implementation, and if the value is 42, we are not going to return 42. We are going to return the answer to life, the universe, and everything. And if not, we are going to return the string value. So finally, we can assert that 42.string is equal to the answer to life, the universe, and everything, and 100 to string is equal to the string representation of 100. And we can also do something like that. We can assert that false to boolean is false, but we can change this, and finally we can assert that false to boolean is true. So it's something like, oh, what are you doing here? It's something like Python when you can define true equals false. Now, categories. All these changes that we do into the method class are hard to revert, are persistent. So with a category, we can do these changes, but in a small piece of code into one closure. And when this closure finishes, the method class changes are reset to its old state. And categories are no special, they are just classes with a static implementation. This is the previous example, and we can use here as a category. into this closure, this method is going to be added to the string. It has to be the first parent, this is important, and if we execute this, it will print Loren. Outside that category, if we execute, or if we try to execute truncate into a string, it will throw a missing method extension. Sorry. And we can also use a category with data annotation. We can annotate a class with a category annotation, the type of the class we want to change. And here we don't need static methods. Static here and not static, and we use in the same way. It's another example. I'm creating a file binary category that receives a file and a URL, and it downloads this URL into that file. And we can use like this. We create a new temporal file, and using this category, we can write that code. The file will be this temporal file, and the URL, it will be this. And if we execute that code, it will print the temporal file in which this Groovy logo has been downloaded, and we can open this temporal file with an image viewer, and of course, it is the Groovy logo. So here, with this code, we can write, or we can use this static method in a more groovy and idiomatic way than using just like this. Extension modules. They are another way to create some or add new behavior to our classes. They are a jar file with some methods that are going to be added to the target classes. We have to pack these classes in a jar, and we have to create a meta information file with the list of classes that we want to use as a model. We only have to put this jar into the class path to enhance the classes. And these classes needs to be, again, public and static. So here I have, again, our string utils example. I have built a Gradle build to build that jar. And here we create this meta information or metadata class. The name, the version, and this is the class that we use as a module extension. We can write a lot of classes with commas, separated commas, and we can write this spoke specification. And we can check that Loren ipsum.truncate5, it will be Loren. And here we can see that we are not modifying the meta class, we are not annotating this class. File is on the class path, this jar, and Groovy enhance the string class. So here we can, if we can build that, we execute Gradle build, and we can compile one class, this extension sample Groovy, with this jar file into the class path. So this assert will be true. Mixins. With a mixin, we can bring or mixing some behavior from another classes, from multiple classes. When Groovy invoke a method, it will invoke first this method into the mixins, and then if that not exists, the method in the target class will be called. We can mix some from multiple classes, and the last mixing added wins. And again, mixins cannot be easily undone. So here we have superpowers, Spider-Man power. Spider-Man has spider sense. Cyclops can fire laser blasts, and Superman can fly and has super speed. And we have a regular person class, and we mixing these behaviors. So now we can create an instance of that class, and we can check that this person has spider sense, can fly, and has super speed. Here we are modifying this class with the @mixin annotation, but if we cannot modify the code, we can also use this this we can write this code just like this. Person.mixin and the list of mixins we want to add into this person class. And now this person can also fire as a class. Method synthesis. We have been injecting methods, but we are injecting methods that we know how these methods are called. When we write the code, we decide the names of the methods that we are going to implement. With method synthesis, we don't know these methods. They are going to be executed and created on the fly. And this method may not exist until we call it. We are going to use invoke method missing, and property missing, and we're going to talk a little bit about this intercept, catch, and invoke pattern. We're going to intercept into the execution. We're going to generate an implementation on the fly, and we're going to cache it, and finally we're going to invoke this new execution. Here we have a class with some properties, some methods, and we have these helpers. We can check if that instance responds to this method, say hi, it will be true, or say hi to with this string parameter, it will also be true, but the person class does not respond to goodbye. And the same with properties. This class has a property name, and it does not have a country property. And finally, we create a new person. We add a new property into this meta class, and with has property, we can check that this instance has this property. We can also create an arbitrary instance on the fly using the expand node. We create 2 cars, and we can also add this. Imagine these variables are read from, I don't know, external from the database. So here we are adding this property year and this property kilometers, and we print this, it will be the result. And here we also creating another class, and we adding methods. We add the turn method and the drive method. They are closures, and we can execute just like this, and it will be the execution. Method missing. This is a real example. We have some requirements for one application. We have to notify our users in our application. There are, I don't know, something like 35, 40 different notifications when the user receives, for example, when he gets a new follower, he receives a new private message, and we have to send this notification to the user using these 3 different channels: email, internal notifications in the app, and mobile push notifications to the mobile phone. And finally, we can only send this kind of notifications not by all these 3 channels, but also only by 1. So how do we implement this using metaprogramming? We create this channel with all the methods, all the different kinds of notifications, and we create 1 channel for every type of notification. And for example, when the user has new follower, it will be sent by push, but when the user has a new message, it will not be sent by push. And now, these are standard Groovy classes, and now here we have a notification service. This is a Grails service with the list of the channels that we are going to use. These channels are going to be injected by Spring, and we are implementing the method missing. So, for every single method that does not exist on that class, we are going to execute this code, this method. Our final target is to execute. If we want to execute or write code just like notification service dot send new message, or notification service dot send new follower. Here we are creating the implementation. Remember the previous intercept, catch, and invoke pattern. We are creating the implementation. It's a closure, and for every channel we get this method name from this execution from the meta class, and we're going to invoke it. Here we are saving, we are caching this implementation into the method class to reuse it later, and finally we are executing here. And this is just a method that exists on that class. And now we are using this notification service. We create a new instance. Remember, when you use Grails, you do not have to do that. Grails will inject these channels. We can check using the response to method that notification service doesn't has this new follower, send new follower method, and we execute this notification service, send new follower, and this will be the execution. The method missing is executed for this name with these arguments. Here, now we're going to implement this, and for every channel we're going to execute this method in every channel. So this send new follower use email and mobile. Send new follower email and mobile, not internal notification. So we are notifying the user. And finally we can check that now this class responds to this method. If we execute this send new follower method again, it will not be handled by method missing because the method already exists on the meta class because we were catching it before. And finally, if we execute the other method, it will be the same behavior. We intercept, we create the implementation on the fly, we catch it, and finally we execute this. And if the method exists, it will be used. So now I'm going to talk a little bit about compile time metaprogramming. I'm far away to be an expert on compile time metaprogramming. If you are interested in this topic, I highly recommend you to go tomorrow Cedric Champo's workshop. He's going to talk more, and he's an expert of this topic. But I can talk a little bit. Compile time metaprogramming is an advanced feature that it's used in special situations and mostly used by frameworks or tools. With the compile time metaprogramming, we can analyze and modify the program structure at compile time. And we can implement this kind of features without explicitly modifying the source code or our application. We are writing code that generates bytecode, not code, bytecode, or at least it gets involved during that bytecode generation. So, AST is how that works. AST is an abstract syntax tree. When the Groovy compiler compiles out our code, it transforms this code into an in-memory representation, a tree in-memory representation. This tree has a root node and some branches and leaves, and during the different compilation phases, the Groovy compiler adds new nodes, rearranges them, or even delete some nodes. And finally, this tree is converted to bytecode. And with compile time metaprogramming, we can hook into these phases to modify this tree and modify the final bytecode that is going to be generated. Here are the 9 steps of the Groovy compiler, and the 3 that are underlined are the steps that we can hook to use or to create an AST. We can also hook into the other, but it will be way too low level for us. And Groovy also provides a lot of out-of-the-box AST transformation. Remember when I said at the very beginning of the talk that you were wrong? You have used one of these all notation. At category, compile static, at delay, there are a lot of them, and you have used it. Also, you don't know that they are AST transformations. And with Groovy we can create 2 types of transformation, global and local. Global transformations, we do not have to annotate anything. We do not have to write at category, at mixin. They are global. They are executed and applied to every single piece of code during the compilation phase. And because of that, this kind of metaprogramming of these AST, global AST transformations can slow down the compilation time. As they are global, we have to create a metadata file and put into jar file, because Groovy needs to know that we want to create a global AST transformation. And for example, Grails use this global transformation in Go. And local transformation, they are only applied to the annotated code. So they are more, we have to annotate that code. They are only applied to that code, and they are easy to debug. And in jar file, we only have to annotate that code. And the steps to create a local AST transformation are just three. We create an interface, we define the AST transformation and implement it, and we finally enjoy it. Here is a little example of a local AST transformation. Here is we want to write that code, a class, and we are going to create this @version annotation. And with this AST transformation, we want to, this code will be converted to that code at compile time. We are going to add this static final string version property with this value. So the first step is to create an interface. It's a standard Java interface. But here, with this annotation, we tell Groovy that this annotation are going to be implemented into this class. So now in this class, we are implementing the AST, the local AST transformation. We extend from extra AST, and we have to override this visit method. So when Groovy compiles the code and reach to a version annotation, it will going to execute this code. Here, we can also notice that we are indicating the phase in which we are going to apply this transformation. And we check the nodes, we check that the first node is the annotated node, the second one is a class, because we want to annotate a class. And if it's true, we get the annotation, because it is the first node. We get the value that we have right here, 1.0. And if this value is a constant expression, I mean it's a string, it's not a variable, we add into that class node, nodes 1, this field, name version, it will be public, static final, it will be a string, and finally we add the value, this version. And if not, we are going to throw a compile error. We can execute Gradle build to build this annotation, and if we execute this code with this jar into the class path, we annotate the class and we can print the version, and it will be 1.0. If you are not sure, or if you don't believe me that this code has changed during the compilation phase, you can also compile this class and open it with the compiler, for example, GDGuide. And here we are opening the class, and we can check that this method, or this attribute is added to the bytecode. It's not runtime; it's into the bytecode. We have to create AST nodes, but what is this? We are not Groovy committers, so we don't know how to do that. I recommend you to check this documentation. There are all the information about every node we can use. For example, block statement, return, if statement, there are a lot of them. You should use an IDE. You can also use Beam, Emacs, Sublime, whatever you want, but if you use an IDE, it will help you a lot. And you can also use the Groovy console. You can write, for example, this code, open the Groovy AST browser with Ctrl-T, and it is the AST nodes that Groovy creates for that code. For example, here you have a method node, say hi, a parameter, name, block statement with a return, a GString, constant, variable, blah, blah, blah. But is there an easy way to create an AST? Yeah, you can use the AST builder. The AST builder provides 3 different methods to help us to create an AST. we can use build from spec. It is an DSL over these class nodes. So we write this code, but instead writing new block statement with a lot of patterns, new return statement, we use this as a DSL. I mean, block statement, curly brace, return statement, something like that. We can also use build from a string. With this helper, we write the code that we want to add or we want to create the AST form into a string, and we pass this string into the builder, and the builder will return the AST nodes, and we only have to pick this node and use it, or inject, or do whatever we want. And finally, we can use this other helper, build from code. With this builder, we write directly the code we want to create the AST, and the builder will return all these nodes. So, as a final recap, why we should use all of this? Because Groovy provides a lot of metaprogramming features out of the box, so it would be a pity not using them. Some of them at least are very easy to use, and they are very, very powerful. We can also write better code, organize our code base better. We can add a lot of behavior, and we are Groovy developers, so we can take advantage of all the power that Groovy provides us. We are not Java developers. And because finally, Groovy, it's Groovy. So thank you very much. These are my contact information. I'm going to push the code to my GitHub account. I'm going to publish these slides into a SlideShare. I'm going to tweet it. And please, if you have 1 minute, please go to this URL. And it's a Google form with only 3 questions. They are anonymous, and it will help me to improve this talk or improve my talking skills. So, any questions? Yeah.
My question is about predictability. I think metaprogramming, metaclasses, modify behavior in runtime, especially in runtime, more than 5 times. It makes your code lose predictability, and it's very bad.
Well, it depends on how do you write this metaprogramming. If you overwrite it to a string into the integer, put this jar into the class path, and your team doesn't know, yeah, you are such a but you can create a lot of features using this metaprogramming. It's very powerful. If you can, I think you have to talk with your team and decide how are you going to use metaprogramming. Yeah.
What kind of scenarios do you think are good for
the notification example? It's a real example. It's not real because it is implemented using the invoke method. But when I was preparing this talk, I find out that using method missing was a better solution. But with invoke method, it is working, and it allows us to create new channels on the fly with in an easy way. Yes.
As I was listening, would metaprogramming be a good way, or even if it's possible, to change how variables in JSPs, for example, are rendered depending on whatever behavior I want them to have? For example, if a JSP is called by a certain controller or the other controller, a variable is rendered completely different depending on who is calling them.
I don't know if when you are rendering a JSP, you know which controller. I don't know if you know which controller this GSP has been called to render. If you know which controller
render this GSP, you can use this. For example, the truncate method, we are using this to truncate comments in GSPs.
Okay.
I think it'd be very difficult to find out what internal classes are actually doing the rendering of the GSP. That code is really complex and messy, and just figuring out what class to add it to would be really, really difficult. You could do it, but it'd probably be easier to just do it yourself. You know, do the logic inside of the controller without the program.
Thank you. No more questions? Spanish guys, you can also talk in Spanish, and I translate to English. So don't be shy. Yeah.
One controversial question. Compared with Python, I don't know. Then I come more from Python. I'm curious of this community, but in metaprogramming, some metaprogramming parts of Python seem more comfortable for me. So I miss, for example, the dir function to introspect any object, and set attribute or get attribute are really easy to use. And here, I don't find that. So there is some counterpart in Groovy to dir or set attribute, or Groovy sets and the dictionary with the objects.
Yeah, you can use the properties instant.properties, and you will get all the properties of this object, and the same with I think methods. Get method, metaclass. Thank you. I'm not a Python expert. You have here Andrei. He's a really Python hacker. But you can check all the methods or all the properties in a class or in an instance.
Yeah. Get class, get method.
Yeah.
Yeah, little bit PR. Did you saw macro Groovy?
Sorry?
Speaking of compile time AST transformations, did you saw macro Groovy?
I don't understand you, sorry. Okay. No more questions? Thank you.